One of the most fascinating cosmic events astronomers are anticipating is a potential supernova of Betelgeuse, a massive red supergiant star located on the shoulder of the famous Orion constellation. Betelgeuse, nearing the final stages of its stellar life cycle, stunned observers in 2019 when it unexpectedly began to dim, so much so that the change was visible to the naked eye. For several months, its brightness declined dramatically, leading many to wonder if the star was about to die. Telescopes quickly turned toward the crimson giant, and scientists were astonished by the extent of its dimming. Experts believe Betelgeuse is approaching the moment it will explode in a spectacular supernova, marking the end of its life. But when exactly will this cosmic explosion occur, and could have dangerous consequences for Earth? Betelgeuse, also known as Alpha Orionis, is the second brightest star in Orion, following Rigel. Despite that, it remains a key focus of scientific curiosity due to its dramatic fluctuations in brightness, massive size, and distinct reddish color. Interestingly, while alpha-designated stars are typically the brightest in their constellation, Betelgeuse's vivid hue and behavior make it more eye-catching than even Rigel. Ranked as the 10th brightest star in the night sky, and the 7th most visible from regions like North America, Europe, and Canada, Betelgeuse gets its name from Arabic, meaning the armpit of the giant, referencing its location in Orion. This colossal star loses about one solar mass every 10,000 years, shedding material in all directions and creating a surrounding nebula. That nebula spans roughly 30 astronomical units, the distance between Earth and the Sun, and holds 250 times more mass than Betelgeuse itself. At its core, hydrogen atoms fuse under immense gravitational pressure to form helium, releasing vast amounts of heat and radiation. Once the hydrogen is depleted, Betelgeuse begins fusing helium and carbon. Eventually, neon and carbon combine to form iron. However, fusing iron doesn't produce energy. When iron accumulates in the core, the star can no longer support itself and collapses under its own gravity, resulting in a supernova, one of the most powerful explosions in the universe. Stars emit different wavelengths of light, depending on their age and stage of evolution. Young stars glow blue, while older stars like Betelgeuse appear red. Ancient astronomer Tycho Brahe described Betelgeuse as ruddy, while even earlier Chinese astronomers noted it appeared yellow, suggesting that Betelgeuse may have once been a yellow supergiant. Massive stars like Betelgeuse burn through their fuel rapidly and often live fast, short lives, typically only around 10 million years. Compared to our Sun, which has more than 5 billion years left, Betelgeuse is racing toward its end. The star also undergoes two known cycles of brightening and dimming, one every 5 years and lasting around 100 days. These fluctuations are believed to result from the expansion and contraction of its outer layers, altering both its size and surface temperature. Public interest in Betelgeuse surged in 2019 and 2020 during its unpredictable dimming episode. After a dramatic drop in brightness, the star briefly brightened again. Some researchers speculated this could be a signal of its approaching end. Despite extensive study dating back to the 1st century BCE, the exact cause of the dimming remains a mystery. Betelgeuse is currently moving through interstellar space at about 30 kilometers per second after being ejected from its birthplace in the Orion OB1 group, the same region that includes Orion's belt. The star's movement creates a bow shock extending more than 4 light-years across. Accurately measuring the distance and diameter of red supergiants like Betelgeuse is notoriously difficult, complicated by several astrophysical factors. To add to the complexity, Betelgeuse is a pulsating star. Its size and brightness are constantly in flux. Betelgeuse's size is not constant. It fluctuates over time. This, combined with the dimming of its outer layers, causes its observed glow to change in color and fade the farther we view from its center. Moreover, the star's expelled material plays a key role in both emitting and absorbing light, significantly influencing how we perceive its brightness. Observing Betelgeuse directly is complicated, as its apparent size varies depending on the wavelength of light used. These measurements can shift by as much as 35% across different parts of the spectrum. In July 2009, the European Southern Observatory used its ground-based Very Large Telescope, VLT, interferometer to capture images revealing a massive plume of gas extending up to 30 astronomical units from Betelgeuse, roughly the distance between the Sun and Neptune. This was just one of at least 6 large-scale outflows recorded from the star. These mass ejection events may offer critical insights into how massive stars lose material toward the end of their lives, a process that may be central to their eventual collapse and destruction. The internal dynamics of Betelgeuse's extended outer layers remain largely mysterious, as does the precise mechanism by which red supergiants shed their mass. Yet, these stars are essential to the cosmic recycling of elements throughout galaxies. Thanks to advancements in interferometry, astronomers are steadily moving closer to solving these stellar puzzles. In 2019, researchers using the Hubble Space Telescope and other observatories discovered that Betelgeuse had expelled a significant portion of its outer shell, resulting in a massive surface mass ejection SME. While our Sun also produces solar mass ejections, Betelgeuse's event was thousands of times more powerful, releasing about 400 billion times the mass of a typical solar eruption. This event is believed to be the cause of the star's dramatic dimming, observed in October 2019. By mid-February 2020, Betelgeuse had lost nearly two-thirds of its brightness, fading from magnitude 0.5 to 1.7. By February 17, 2020, its brightness had stabilized for over a week, and as of February 5th, the dimming seemed to have stopped altogether. However, this drop in visible light wasn't linked to a core collapse, as no significant changes in the star's infrared output were detected by February 24, 2020. When Betelgeuse eventually explodes as a supernova, it will be one of the most spectacular astronomical events ever observed. Even at a distance of 640 light-years, the blast will be so luminous that it may outshine the full moon and remain visible during the daytime for several weeks or even months. Scientists predict that the explosion will release more energy in just a few seconds than our Sun will emit over its entire 10 billion-year lifespan. The light from this explosion will travel through space and eventually reach Earth as an intensely bright point, unlike anything we've seen before. But there's no cause for concern. Despite how close it may seem, Betelgeuse is still far enough away that its supernova will pose no danger to Earth's biosphere or life. Instead, it will offer a once-in-a-lifetime opportunity for scientific discovery. As of recent years, Betelgeuse has returned to its normal brightness levels, though its unusual dimming episodes remain under close observation. Scientists are using cutting-edge tools like the James Webb Space Telescope, the Hubble Space Telescope, and ground-based instruments such as VLT and ALMA. These are helping track changes in surface brightness, patterns of convection, and ongoing mass ejections that indicate the star's instability. A leading theory is that the dramatic dimming in 2019 was caused by a massive dust cloud formed during one of these eruptions, temporarily obscuring the star's light from our point of view. Understanding such events in Betelgeuse could help astronomers better decode the life cycles of massive stars, especially those on the verge of going supernova. These insights may also improve our ability to predict similar phenomena in other galaxies and explain how heavy elements are distributed throughout the cosmos. The cosmos is a vast foundry, forging and dispersing elements like iron and gold across space. Betelgeuse, a red supergiant nearing the end of its life, serves as a ticking cosmic timepiece, one that's slowly winding down. It could explode tomorrow, next year, or even 100,000 years from now. But whenever that moment comes, it promises not just a breathtaking galactic display, but also an unparalleled scientific opportunity in our modern era. Understanding the life and death of stars like Betelgeuse isn't merely academic. It's essential to unraveling the very structure of a universe. Massive stars act as elemental forges, creating heavy elements during their lifetimes. When they explode in supernovae, they scatter these elements into the cosmos, enriching nearby interstellar clouds with the raw materials for new stars, planets, and potentially life itself. Betelgeuse's eventual supernova offers a rare chance to observe such a momentous event up close. Most supernovae studied by modern astronomers occur in faraway galaxies, limiting the resolution and data available. But Betelgeuse lies within our own Milky Way, relatively close in astronomical terms, making a prime candidate for detailed observation. Scientists could track every phase of an explosion and aftermath with unprecedented clarity. This opportunity is especially valuable for those studying neutrinos and gravitational waves. A supernova doesn't just emit visible light. It floods the cosmos with neutrinos and may generate detectable ripples in space-time. If Betelgeuse explodes, observatories like LIGO, Virgo, and IceCube could capture these signals, yielding insights into stellar collapse, the nature of matter, and the fundamental forces shaping the universe. Astronomers are closely monitoring Betelgeuse not just for its impending demise, but for the lessons it can teach about stellar evolution. Red supergiants are among the most mysterious and least understood phases in a star's life cycle. They are immense, unstable, and notoriously difficult to model. However, breakthroughs in space telescopes and high-resolution spectroscopy are gradually unveiling their secrets, and Betelgeuse may soon offer the ultimate case study. For now, Betelgeuse continues to pulse flicker and intrigue. While its brightness may appear stable, scientists remain vigilant, prepare to record every subtle shift that could herald a supernova. When the explosion finally comes, be it tomorrow or millennia from now, the data collected could transform our understanding of how stars are born, live, and ultimately die. Until then, Betelgeuse stands as both a celestial wonder and a cosmic countdown, glowing in the night sky and sparking the imagination of astronomers around the world.